Hey guys, welcome. I'm disappointed that we're not having class today, so what I thought I would do is show you guys what we would have been doing if for the purposes of actually having class. So what you guys see here is Blackboard. This obviously has not changed very much, but I just want to let you guys know what I've posted for you. So as always, when you go to the virtual tab, now I have posted right here for you virtual set number 1, key number 1. So right now you guys had the FRQ that I did last week and then the multiple choice without the work. So now you guys can check the multiple choice with work. So if you're not really sure on how to get a question, you can click on this link right here. And then the FRQ that you guys did, there is the work for it and then the rubric on the right side. And what we're going to do today is the problem set number 2. So we're going to do that now. So if you guys want to take a moment and go to Blackboard and print that out, you can work on it. We're going to do the same thing we did before with a really awesome FRQ. And then right down here is the answer to the FRQ that I'm going to be working on now. And then the 15 multiple choice answers. Again, this is just going to be what the answers are A through D without the work. And then you guys will have a submission of this assignment next Monday at 11:59. For everyone who turned it in, I really appreciate it. I looked at it. You all earned extra credit for it. So I know that some of the emails I said but, not the extra credit, so you all earned it. If you got a response from me, you got the extra credit. For the people that didn't turn in the first assignment, not all is lost. I encourage you guys to continue on working with this. A lot of this, I know all of you guys, it's all about your grade, but, I want you to pass the AB exam. And what I'm doing right now, I think is very beneficial because it allows you to see what kind of concepts are going to be on the AB exam. I mean, we're really looking at 2 or 3 FRQs, and as you guys see in the first FRQ we did, it covered a lot of stuff. The derivative of the natural log, the chain rule, the product rule, derivative of sine and cosine, speeding up, slowing down, what else? A lot of other stuff, I can't remember now. And so the FRQ I'm going to do today is also going to require a lot of stuff. So let's actually look at the FRQ. And again, it's on the problem set for AB set number 2. And so here it is. And this FRQ should be very familiar to you because this was the last thing that we did before we all had to go virtual. And so I want to give you guys a chance to look at the question. And then at any time, you can pause it and, ask questions. Obviously, email me if you have questions. And then we can talk about the questions as well. So I'm going to try to go slowly and see what we can do with this. So, yeah. Anyway, so the question says, consider the differential equation. So for the differential equation, right? So that first word right here, first words, differential equation, should let you guys know that it's a equation with a derivative that has either x's, y's, or both. In this case, we actually have a derivative that has x's and y's. So it was implicitly differentiated. And that's another thing that please make sure you guys know how to do. The problem set for 2 has a couple of implicit differentiation questions where remember when you're taking the derivative of x, it's just dx over dx, so really it's just 1. If you take the derivative of any variable with a y, then it's dy over dx. You have to remember to add that in there. And we'll talk about that a little bit later on. Okay, so here's our derivative, right? So that's what this is. A differential equation is the derivative of our function. And so it says on the axis provided, I apologize guys if you print this out, for some reason this piece, this little picture right down here is not on your version, but it is on the homework version. So it's just pretty easy. It's just the XY graph. Here's 1, 0, 0, 0, negative 1, 0, 1, 1, 1, 2, kind of stuff like that. And so what we're asked to do is we're trying to show a slope field for this differential equation of the 12 indicated points. So part A, it's actually asking us to sketch the slope field for the given differential equation, and it's asking us for 12 points, and I'm assuming that on the AB exam, they're not going to actually ask for 12. But this is pretty straightforward, because remember, all you have to do is just plug in the points, and so like when x is equal to 0, right? So when x is equal to 0, then this derivative is going to be 0, right? This term here is going to be 0, therefore anything multiplied by it is going to be 0. So my x is equal to 0, then my derivative will also be equal to 0. So then over here on our number line, when x is equal to 0, which is going to be our y-axis, right? This is where x is equal to 0. Then we're going to have little mini lines, little slopes of horizontal lines. So you guys will see this, right? And then if we ask y to be equal to 1, right? I might get rid of my face here. When y is equal to 1, then you guys will see that this will end up being 0. So again, my derivative will also be 0. So when y is equal to 1, then my derivative is also equal to 0. So y is equal to 1 is right here. So we're going to do that. Usually on the AB exam, if this is the case, you get a point for all of the horizontal slopes or all the vertical slopes. So this is 1 point for this. And then the other point is to make sure that all the other 6 points are actually correct. And how do we find those 6 points, right? How do we look at those 6 points? Well, you just got to plug in, right? We got to plug in. Well, what happens when y is 0, right? So what happens, let's look at the x-axis for a second. What happens when y is 0, right? Well, when y is 0, let's go right here for this one. So when y is equal to 0, then we're going to have negative 2x times 0 minus 1, right? So negative 1. Well, when x is 1, so let's go down here for this. When x is 1, so we're looking at the point 1, 0, right? 1, 0, which is right here. When x is 1, we're going to get negative 2 times 1 times negative 1. Well, this is going to give us a positive. Really don't care about the number, right? It's going to give us a positive number. It's going to give us 2, right? It's going to give us 2. So that means it's going to be positive. So I'm going to actually make this positive 2. Well, what happens when x is negative 1, right? So let's look at the point right here. When x is equal to negative 1, then we're going to look at the point negative 1, 0. And so we're going to have negative 2. And we're just plugging in, right? We're plugging into our derivative. And so we're just looking at our problems right here. So it's going to be negative 2 times negative 1. I apologize about my handwriting, my gosh. And so it's going to give us positive 2 times negative 1, which is going to give us negative 2. So we're going to have a negative slope, right? It doesn't really matter. And then that's what you do for the other 4 points. So you guys can take a second and pause this and try them if you want to, or you can just kind of go ahead and look at the, continue with the video and I can tell you how to do them. Okay? All right, guys, so when I'm doing this problem, I just noticed that I chose the wrong point. So it's clearly 1, 2, not 2, 2 that I'm actually asking you guys to do. The reason why I'm not re-editing this is because it's going to give you the same value for this. So you're plugging in 1 instead of 2. Since they're both positive numbers, it's really not going to matter at all if it's negative 2, negative 4. Remember, the whole point of these slope fields is the fact that it's negative. And then we're going to look at this point right here, and this is going to be at 1, negative 1. And so just like before, we're going to start plugging stuff in. So we're going to get negative 2, and x in this case is going to be equal to 1. And then it's going to be negative 1 minus 1, right? And just like before, we have a negative number here, right? So we have a negative number, then we have a positive number, and we're going to multiply that by another negative number. So we know that this answer is going to end up being positive, right? So like I said, in slope fields, we don't really care about the actual values for them. And then the last one is going to be a negative 1, negative 1. So we're going to keep plugging values in. So we have negative 2. X is now a negative 1. And then we're going to get negative 1 minus 1, right? So a negative times a negative times a negative is also a negative. So our value here is negative. And so that is what the slope field will look like. Okay, guys, so I went ahead and erased everything for the slope fields. And so we're going to now gear ourselves over to part B. And so B is asking us to, and so again, I told you guys last week, there's always this little wonky, weird question, right? That was one where we had to get everything in terms of one trig function. So for part B, this says, shows that any point with the initial condition that is along the y-axis, right, along the y-axis, where y is greater than 1, creates a relative maximum for its particular solution. So you guys have to remember that for a relative maximum, our derivative has to be equal to 0. Now, normally what you would do is you would be having, let's say this derivative was in terms of x. Then you would find the critical values, right? You set your derivative equals 0, you'd find your critical values, and then you do yourself a number line. 3, let's put 3 here. And you do negative and you do a positive. Well, if you look at this, and let's go and add a 5. Oh, my handwriting, I'm so sorry. So remember, negative to positive is a minimum, and then from plus to minus, right, is a maximum. So it's kind of like we're going down, we're leveling off, we're going up, and then we're leveling off, right? So we would have a relative maximum at x is equal to 5. Well, that's the assumption that we're making if our derivative is only in terms of x. Well, in this case, we have a y value. So what we also can do is we can do the second derivative test. Now, I know that's been a long time since you guys have seen that, but what that means is that if my derivative is 0, and so we know that since it's along the y-axis, right, the long y-axis, we know that that's telling us that x has to be equal to 0. So for part B, we're looking at when x is equal to 0. Okay, and you guys can say, just based on our slope fields that we just did here, when x equals 0, yes, our derivative is going to equal 0, right? When x is equal to 0, our derivative will equal to 0. So what we have to do is, if we know this, we know that x equals 0 is a critical number or a critical point, right? Because remember, when your derivative is 0, you have a max or you have a min, right? You have either a mountain or you have a valley or a peak. Or sorry, a peak. So what we can do is find the second derivative. Now this is where we have to use implicit. And this is why these FRQs are awesome, because we did a slope field in A, and we're going to do implicit differentiation in part B, right? So I'm going to go ahead, I wrote the derivative right here for us. So let's find the second derivative, and then I'll explain to you guys why I'm finding it here in a minute. So remember, we have to again use the product rule for this. We have one term, or one function, which is negative 2x. Our second one is y minus 1. So then we're going to do negative 2x, and then we're going to multiply by the derivative of what's inside the parentheses. Well, remember, the derivative of y, because it's y, is actually going to be 1 dy dx. And remember, the derivative of a constant is just 0. So the first part of our derivative is negative 2x times dy dx. And again, like I said, that's something you most likely will probably see in 3 weeks. And then product rule, p for plus our second, which is y minus 1, and then we're going to multiply by the derivative of what's right here, which is going to be negative 2. Okay? And so let's clean this up a little bit. The first thing that I want to do here is I want to go ahead and write out what dy dx is. Well, guys, dy dx is written right here. It's right there. So it's going to be negative 2x. Because remember, this is just the first derivative. It's given it to us. So it's going to be negative 2x times y minus 1. And then I'm going to go ahead and just rewrite y minus 1 times negative 2. And some of you are like, well, why didn't you distribute the negative 2? Well, I want to make this as neat as possible. So I'm going to keep my notation right here for this. Remember, notation's key in these FRQs. They both have a y minus 1. So I'm going to go ahead and pull out a y minus 1, because I want to try to get my y's and my x's separate, and that's an easy way to do that. There's only one term with a y in it, and it's got a y minus 1, and they're both in the front and the back, or in the first term and the second term. So then what's left over is going to be positive 4x squared, and then this is going to be minus 2. All right, so this is our second derivative. This is our second derivative. So again, I hope that if that makes sense, maybe rewind the video and go back through it, or, talk to me, email me, and I can kind of go through a little bit more. But I used the product rule. I plugged in what dy dx is. I kind of simplified a little bit, and I said, okay, well, they both have a y minus 1, right? A y minus 1 in both of my terms. So I pulled that out, and then what was left over is what I put right here. And so now we have to go back and look at the question. Well, the question says that, remember, we started out with x is equal to 0, right? X is equal to 0. So if when x is equal to 0, let me change my color here. So when x is equal to 0, this term right here is going to be just negative 2, right? And then right here we get a y minus 1. Remember, the stipulation here is we are assuming that y must be greater than 1, right? So I'm looking at what points the initial conditions show that at any point with initial condition along the y-axis where y is greater than 1, we create a relative maximum. So let's go back down here and say, well, when y is greater than 1, I know that this first term is going to be positive. It has to be, right? Anything greater than 1 is going to make this positive. So just like before, what I can now say is that through the condition that y is always positive and that x is 0, because it's on the y-axis, right? On the y-axis, then I can now conclude that dy, or the second derivative, will be less than 0. It's going to be negative no matter what values I plug in, because x is always 0, so this is always going to be negative, and this is always going to be positive. So I know that based on those two conditions that I was given, my second derivative is negative. So guys, remember, what does second derivative talk to us about? And again, this is why I love these FRQs, because there's so much interlaid into these questions. So when we look at a second derivative, remember, this has to do with concavity. So when my second derivative is negative, I'm going to be what? I'm going to be concave down, right? Concave down. And if I know I have a point here, remember that at x equals 0, right? At x equals 0, I know that I have a tangent line. The slope of my tangent line is at 0 because it's a critical value. Therefore, I know that there has to be a relative maximum at x equals 0. Okay? Now, I know some of you guys probably looked at this like, oh my god, I would never figure this out. But, you know, just kind of think about it a little bit. And like I said, if you did not know how to do B, then go to C and do the differential equation question and then come back to it. Skip around and make sure you guys do your stuff that's comfortable. Because like I said, I think this question was worth 3 points total. The rubric is going to be posted for you guys. But just knowing that we have a critical value, right? Because a relative max and min, they want you to understand we have a critical value and then solving the derivative, right? Solving the second derivative using implicit differentiation, and making sure that you guys remember that you have to use the product rule here. You can't just take the derivative of the first and the derivative of the bottom, the one on the right, and then call it a day. You actually have to take the derivative, all right, using the product rule. So that's the answer to part B. So we have now showed through second derivative, the fact that concavity is negative at this point, we have a relative max because there's a critical value. So we need the fact that we have a critical point, we have our second derivative, and we know that it's going to be concave down. All right? So again, I hope that that's okay with you guys, and hope we're good. So let's move on to part number C. Okay, so I went ahead and erased everything and get us ready for part C. So part C, whenever there's a slope field, there's always going to be part C here. It says find the particular solution given the differential equation, right? And it's given us this initial condition of f of 0 equals 0. And this is usually how we find our C value. So whenever we're doing differential equations, guys, for part C, when you see differential equations, you got to think about, oh, we need to separate our variables. Okay, and what does that mean to separate our variables? That means all of our x's on one side, all of the y's on the other. So remember, the first thing we're going to do here is we're going to multiply by dx, and we're going to divide by y minus 1. So we're basically, because this is kind of like over 1, right? Over 1. So we're going to go ahead and get that dy over y minus 1. Please make sure that you divide by this and you don't just move it to the other side, right? So I'm just dividing both sides by y minus 1, and I'm going to multiply both sides by dx. Usually, they give you a point for something like this. It's just separation of variables. That's what's been in the past. And then what we ask that you guys do next is when we're solving the differential equation, hopefully you know before I tell you what we have to do to both sides, and that is to integrate, right? We need to integrate both sides, and you need to show that you're integrating. You need to show that step, all right? So this part right here, this left part, I hope that we know what this is, right? We would have to use u sub. I'm going to go ahead and assume that you guys know that u is going to be equal to y minus 1, means du is going to be equal to 1 dy. And so that means that I'm going to have the integration, right, over here to the little side, we'll do this. So the integration of 1 over u du, well, that should scream the natural log of u, right? The natural log of u. So this whole side right here is going to be equal to the natural log of u minus 1. Okay? And then this, we're going to have negative 2. We're going to do x, and remember we're going to integrate x, so it's going to be 2 over 2, and we're going to do our plus c. All right? So you get probably a point for integrating both of those. So the natural log of y minus 1 absolute value, don't forget about the absolute value, and then it's going to be negative 2x squared over 2. So we're going to just really quickly write that out just a little bit nicer for us. So it's going to be the natural log of the absolute value of y minus 1 is equal to negative x squared plus c. Okay? Now this is where I tell you guys we want to find what our c is. Right, we want to find out what our c is, but we're going to hold off on that for 1 second and solve this a little bit more. And the reason why I'm doing it is because I want you guys to remember how we solved exponential growth when we did those kind of questions where we had to remember how to do the e thing. So the next thing that we're going to do here is remember we want to try to get y by itself. And so when we do that, we want to raise everything. We want to raise e to our functions, right? Because remember, e to the a equals e to the b. A and b have to be equal to each other. So we have this. Now remember, this is a law that you guys should know, that e to the natural log of anything is just what that is. Right? We're going to go ahead and drop the natural log here. But right now we should have it, but it's okay. So y minus 1. So remember, e to the natural log of our smiley face is just our smiley face. So it doesn't matter what that is. Right? Okay. And so now this is going to be e to the negative x squared and then times e to the c. And that's remember, you guys remember that x to the a times x to the b is equal to x to the a plus b. So all of these are just exponent rules that you guys should remember from Algebra 2 and Pre-Calc, right? And then we have to remember that what we consider, this right here, this is going to be considered our a, right? Our a. So we're going to write it out again for us. We're going to write out our equation. y minus 1 is equal to some value a e to the negative x squared. And so let's go ahead and now use our initial condition, right? We were told what our initial condition was, right? When x is 0, y is 0. So let's make y 0. So we're going to get negative 1 on the left side. We're going to try to figure out what a is. And the reason why I chose it this way is because if you look at this, I'm going to make x 0. So this is really going to be a e to the 0 power. Well, we know e to the 0 is 1. So we know that a is negative 1. So after this whole long song and dance, this answer is going to be, because I'm coming back to our little guy right here, right? This is where we are. So I'm going to go back and say, well, y minus 1 is equal to negative 1 times e to the negative x squared. Okay? And so our actual final answer, y is equal to 1 minus, I just moved the 1 over, right? 1 minus e to the negative x squared. So that's going to be the answer to our problem. All right. I know that was a lot, so let me just kind of briefly talk about what I just said. So I took the derivative, right? I took the derivative, and then I separated my variables. So I went ahead and put y's on one side, x's on the other, and then after I did that, I'm hoping that you guys don't really need to see the u sub part for this, but it's always nice just to refresh your memory on our properties for natural logs here. That this is a natural log problem, and then integrating negative 2x is pretty straightforward. And then remember, in order to get rid of the natural log, right, we raise everything to e, or e is raised to everything, just from the property that we have here. And then remember, this property simplifies down to whatever this is right there. And then I have this. I use the property of our exponents to get our term a, and sometimes the book's called c or whatever, just some constant. And then I went ahead and plugged in my initial condition to get the value for what a is, and then I plugged in my equation and solved for y. All right. So I hope that makes sense. But again, if you have questions, send me an email. Hopefully office hours works out sometime this week with that. So that's how you do part C. All right, ladies and gentlemen, we are in the home stretch here. The question part D is asking us to find the solution to part C. We want to find this limit. So we want to find the limit as x approaches 0 of our function f of x. And you guys know that y is really just f of x. And some of you guys may be asking, or would ask me if we were in class, like, why does this have a negative exponent? Why didn't you write this as 1 minus 1 over e to the x squared? And that's absolutely true. That's what I've been telling you guys, right? We don't like negative exponents in class. But I knew this question was coming. I know D was coming where we had to find the derivative, and we would much rather use it, rewrite the exponent as a negative, than use the quotient rule, right? So both these answers are acceptable, and I probably should have said that when I was talking about D, but as I was erasing, I was thinking, oh yeah, what kind of questions would you guys probably ask me? So these are both legit answers for the problem, okay? So for part D, it's asking us to find the limit as x approaches 0 of our function. And so we're going to go ahead and write what our function is. All over tangent of x squared. Okay, now, what I'm assuming, and I'm hoping this is correct, is they would read with you. Let's say you do not get question number C right. Let's say your function is incorrect. I'm making the assumption that they're going to read with you somewhat to make sure that you know that this problem is most likely going to be a L'Hopital question, and it's going to be a L'Hopital question. So if you plug in the wrong function, you will, if you do all the correct work, let's say you find your derivative correctly here and the derivative of this correctly here, you will probably get 1 point for doing that. I will tell you that you need to make sure that your notation is great. You drop the limit, you don't get the point. Right? My assumption, I mean, they're probably going to be, who knows what they're going to do this year because it's all being crazy, but you got to keep sure you're doing the limit. What you should not do is you cannot say equals 0 over 0, right? So we plug in 0 here, we're going to get, this whole thing is going to be 0. We're going to get e to the 0 power. We're going to get 1 minus 1, which is 0. So the top part's going to be 0. So here's a little side note, right? There's a 0, and the tangent of 0 is also 0. So you know this is L'Hopital. Now, what I remember telling you guys, right? What I remember telling you guys is when, and again, who knows how they're going to be in this exam, but, you know, one of the things we were told to teach our students is that if it is a L'Hopital question, the first thing that you have to do is actually show the overall limit of the top is 0 and the overall limit of the bottom is 0. So just take a second to write these two things out. And they prefer this over the fact that this is equal to 0 over 0 because it's technically not equal to 0 over 0. All right. So once we do this, then what we can now do is take the derivative of the top, right, and the derivative of the bottom, and then we can try to plug in again. If we get 0 over 0 again, then we got to do it again and again and again and again. But with the AP exam, I'm imagining that one time is probably enough. If you have to do it twice, it's probably going to be a really easy function to do. Okay, so the derivative of 1 is just 0, so we don't care about that. And remember, the derivative of an exponential. So again, this is why these FRQs are so cool, because now we're taking the derivative of an exponential function. Remember, it is that function, and we have to multiply by the derivative of the exponent, right? The derivative of the exponent, which is negative 2x. All right? And so what we can do really quickly is, okay, well, let's just go ahead and let's make this positive, right? Let's just go ahead and get rid of these negatives because it's a positive number here. And now the bottom that we want to do, well, just like in the other example, we had to find the derivative of sine and cosine. Well, now we're finding the derivative of tangent. And I'm pretty much sure that those are the three that you really have to know for this exam. So remember that the derivative of tangent is secant squared. And just like before, we have to leave what's inside of our theta alone. And then we want to multiply, using the chain rule again, we want to multiply by the derivative of what's inside of this, which is going to be also 2x. Now, if you cannot see it, the 2x's are going to cancel, right? The 2x's are going to cancel. Because if you did not see that, and you plugged in the values for, if you plug in 0 to our function here, then you're going to get 0 over 0, and you're like, holy crap, I have to do this again, and I have to use the product rule up here, and the product rule up here, down here, and it becomes a big old mess, right? It's a huge mess. So what we can now say is that the limit as x approaches 0 of e to the negative x squared all over secant squared of x squared, right? So again, notice that if I'm going to write something out and I'm not solving for it, I want to keep sure that I make sure that I keep writing the limit, right? If you don't have this, then this x can be anything. So we're going to plug in 0. We're going to get 0 here. We're going to get that the top number is going to be 1, right? That 0 squared is 0, negative 0 is 0, e to the 0 is going to be 1, right? So this top part is going to be e to the 0. So we have 1, right? The bottom, if I plug in 0 to this, well, 0 squared is 0. So secant of 0, remember the secant is the reciprocal of cosine. So cosine of 0 is 1. The reciprocal of 1 is also 1. You square it, you're going to get 1. So this limit is going to be equal to 1. And that's all you have to do. The only thing else that I should have done, and I have no idea why, I've completely forgotten to do this, is you want to say right here, by our friend the hospital, right? By L'Hôpital. By L'Hôpitals. Okay? So that is the FRQ. That's the FRQ that I think you guys should be able to handle. So like I said, love this one too. So let's kind of go over kind of the topics that we were taught now. We refreshed our memory on slope fields. That's where you kind of plug and chug values in and get your graph. Relative max and min. Extrema is probably going to be on there. Remember that for a relative max for min, then we look at the derivative. If it's just in terms of x, you find your critical values, you do your number line. Remember the number line that I would do in class a million times would be something like this. But you can't forget about your second derivative test. And then C, differential equation. This is such an easy one for you guys to get a lot of points on. It really is. Just remember, separate your variables, integrate both sides, and then just play around with it and see what you guys can do. And then remember, this initial condition here is usually what gets you your C. And then for D, we used L'Hôpital. We used the derivative of an exponential function, and we also used the derivative of tangent. So there are so many things compacted in these FRQs. And I think that's what the AP exam is going to be really geared toward this year, is taking these questions and throwing a lot of small concepts. So that's why I give you guys the multiple choice to go over too, because maybe we need to know how to find the derivative of a tangent function. So it's probably a multiple choice. So what I would ask that you guys do for me is, now that you've seen this, well, here's the second one, and it's pretty straightforward. It's very similar to what we just did in the first one. So we got the homework of the FRQ here. Again, I will post the answer to this rubric on Tuesday of next week. And then, just like in the previous ones, we are going to give you guys, the multiple choice questions that you can see right here. It says should not be done with the calculator because these questions usually are non-calculator. But I just want you guys to remember that you will have a calculator for the AB exam. But for the purposes of learning the idea, remember, you have to show your work. You have to show your work on the AB exam. So if you want to be able to find the derivative of something, yeah, you can go and do Math 8. If you want to integrate something, yeah, you can do Math 9. If it's a definite integral, but you have to remember that they're going to be looking for work on this exam, right? So calculator is great, but it should be only used for you to check your answers only if you have enough time for it to do. But if we keep going down here, we have another U sub question. There's our differential equation, a more direct one, by the way, for you guys, where you don't have to do the exponential stuff. Tangent line, find the value of the derivative. This is a relative maximum based on the graph, all right? So a graph for this problem. And then just a couple other things. I love question number 9 because that's an implicit differentiation question. To students, remember how to do implicit differentiation. Please know that you cannot split that up. Please do not tell me that that's cosine of x times cosine of y. Remember, make sure that you do your rules. And then the equation of a tangent line, right? This is the approximation. This was very, I think this was actually the last thing that I told you guys, I taught you. This is the linear approximation question that we had for you guys to do. Yeah, another differential equation for the value of ky. And then, finding the derivative points. I'm just looking through this. Oh, good. Don't forget about our fun related rates, right? Don't forget about related rates. That could possibly be on there. I think we're going to do an FRQ soon, maybe, with related rates in there. So it's going to be a pretty straightforward one, I'm imagining, but related rates is also there for you. Understanding what something means You guys remember, like, when we talk about, okay, what is h prime? What does the derivative of 5 equals 2 mean? Because remember, we don't like to say differential anymore. We want to talk about what does that mean? It's a rate of change, right? Versus integration and stuff like that. And then this is our, remember, this is our classic question. I hope that you guys know what you have to do with this problem right here, right? And here's the help. Here's the word. All right. So hopefully that makes sense to you what I'm talking about. Okay, so I think that is enough. I think that's good. Yeah, I'm bummed that we can't hang out and, you know, talk a little bit. I mean, based on my little count here, we have like 10 extra minutes, and it would have been awesome if I could ask how you guys are doing. So, you know, if you get bored, send me an email just saying how you're doing. I mean, ask me questions or just whatever. So, I hope that next week we will be able to meet again up in groups and talk and stuff like that. But anyways, that's it for me. I hope you guys have a really good day next time. And yeah, like, let me know if you have any questions, and I'm here for you. So good luck, and I'll talk to you guys later.